So this mini lesson is about what's called the Wilcoxon sign test. And so what we're basically going to talk about here is we have this problem that we had before. Just remind you of it, what it is really quickly here from our matched pairs. And we were asking ourselves, okay, will the introduction of assisted yoga to persons who require living assistance improve their independence? And we wanted to test this with a significance of 0.01. And you notice that we have explanatory variables, assisted yoga, walking as an exercise group, and no exercise treatment. And the no treatment group, though, if you remember, has an insufficient sample size. And when we looked at the sample size or the sample, it wasn't actually very normal in terms of the variable. And so consequently, what we're going to have to use is we're going to have to use something else. We're going to have to use something else called the Wilcoxon sign test. Okay? It's non-parametric, and why it's called non-parametric is because instead of comparing the actual values, what it's going to do is it's going to assign a positive or a negative depending upon whether or not the difference between the before and the after are positive or negative. So consequently, that's what it's basically going to do. And then it'll evaluate whether or not there is in fact a statistically significant difference. Okay? Now, if you remember, we want to see is the difference between the two, because we're looking at, the recovery or improvement in independence, is it positive? All right, so we're going to go into StatCrunch. And in StatCrunch, I have my assisted yoga match pairs open. I'm going to go to Stat, and then I'm going to go to non-parametrics, because that's what this one is, and it'll be the Wilcoxon signed ranks. Okay? Then I'm going to take the score before, I'm going to take the score after, and don't forget, okay, that we're going to have to group these guys, and we're going to have to group them by treatment, okay? This one here, we're going to set the median equal to 0, and HA, the median, is going to be, our alternative, is going to be greater than 0, okay? And then I go in and compute. What I get here, okay, is I get some information about my no treatment group that basically says that the estimate for the median difference is about 3.5, okay, in terms of its change, okay, and it tells me that my p-value is less than 0.001. And so consequently, what this gives me is it gives me information in terms of whether or not there's actually a difference for no treatment. And the answer is yes, there is, because p is less than alpha. Alpha was 0.01, okay, and we got a 0.0001. Okay, so what we're going to do is we basically use this and say, okay, well, I got p. P was less than 0.0001. Alpha was equal to 0.01. So p is less than alpha, and we reject the null hypothesis. What does that tell me? That tells me basically that I have found actually a difference. Okay. And that's it. That's using the Wilcoxon sign. When do I use it is an important question. Okay. I use this test when the requirements for the matched pairs have not been met. That's what I do whenever I use any kind of parametric, or non-parametric, excuse me. Okay, it's called a non-parametric test because it does not assume a particular distribution. Okay, and that concludes this mini lesson.